Let's go through another traversal mechanism on a binary tree. Again, we're talking about binary trees in general, not specifically binary search tree. So the property of these nodes with respect to their value don't really matter. The second one is called preorder. We talked about in order. So preorder means I want to visit my root first, right? At any given point, root could be this, right? So if the root is F, then with respect to its left and right would be B, H, G, right? Something like this. So root first means P is going to be printed, right? And then let's take care of this this code next. So just like what we did for in order, we're going to quickly write a preorder function. So this preorder function will be done recursively, called upon recursively to enable that traversal. So in the beginning, we want to check, right? As you with any traversal mechanism, you want to check to see if your node, right, is null or not. If this is a zero node, meaning it's not going anywhere, then right, you don't want to do anything. And we call that your pre-order, your in order, your post order, any of these recursive calls, they don't really return anything here. Now, in the industry, you can have a traversal mechanism. You don't have to print any value out. You can do anything you want, but you want to do something, right, upon landing on that specific node of interest. So in this case, we're not going to do anything. We just want to print out the value of the node that we're visiting. In this case, which is node value, right? And note that the reason why we're doing this is because recall that preorder means I want to visit my my root, which in this case is my node, starting from the very beginning. And then next thing you want to do is recurse into that node's left subtree. And after that's done, recursing into its right subtree. So the way that we write it is basically just calling itself. But in this case, I wanted to visit all of its left first, right? And then next thing I want to do is recurse into its right. So let's just double check that this code is correct. First of all, the stopping function is, or my base function is when null equals 0. So base case, when null equals 0, returns. So this takes care of basically putting a stop, right? Putting a stop to these recursions as long as node reaches that. So this is the beauty of Java, right? When you pass a node in there, this node structure has a default of null with respect to the right and left. If there's nothing else, basically that means when you're finding, let's say G is a leaf node, right? And by default, G has both right and left instant variables, and both instance variables have a default null. Okay, so this allows our base case selection criteria to kind of return the flow of control back. So this ends, right, the recursions. Otherwise, you're going to get infinite loop here. Okay, so just to illustrate, what this means, you can briefly just kind of look at it, for P being the root, right? So P is printed right here. What is the next one? Well, the next one is going to go into the pre-order, because as soon as this is done, right, it goes right into the next one, pre-order node left. And this node left is going to go through the same logic again, like no equals null, which is not true. And then it's going to print out itself, right? So immediate, you can see that F is going to be printed as soon as P is done, right? P is done, and then F is going to be printed. So this is a little different than the in order, right? In order basically recurses all the way to the end and kind of bubbles back out. But pre-order does not do that, right? Pre-order basically says, I'm on this left side, and let me just kind of charge forward and print out whatever the nodes that I'm looking at because of this, right? The second line of code or the third lines of code inside this pre-order function. So without further ado, let's move on to the actual code. So this is the same replit, and just to make it really, really simple, I'm just gonna copy the pre-order traversal, basically the entire node structures that we have from before. And just to illustrate, let me do this again. Our tree looks like this. So we're gonna have a node starting with 15, right? And then its left subtree starts with 10. Right subtree is gonna have a value of 20. Okay, and the left one here to its left, a value of 8. Now, this is not a binary search tree, so we don't really care about the order of these values. Okay, this is just a what we call binary tree. Okay, it's a BT. Okay, so let's apply pre-ordered traversals to this one. Let's go back to the code. So just to build a tree on, and just to save some time, I'm just gonna cut and paste this thing into it. So this is our pre-order, right? This is the tree that we have on the left side here. And this is our pre-order call. Now, I don't have this defined yet. So let me just build this pre-order. This is a static function because we're calling from main. Main is static. Static calls the static, which is of the class and not of the instance here. Okay. Pre-order. Now this one takes our node, right? And then the logic kind of sits right in here. So in order for this to work, and just remember that we're checking, right? If node, right, equals null, we want to return it, right? Return right here. Okay. Alternatively, you can just, do this too. If not null, right? And then encapsulate the whole thing here. And the first thing I want to do is to print out, my node right here. My node is going to have a value plus, well, I'm going to leave a space for visibility reasons. And then, and this one is done recursively, just like what we did before in a previous page, right? And that's it. Okay. Now you can pretty much extrapolate. If you want post order, that means this entire output line is going to be at the end. So this is pre-order, meaning that your node value is going to be printed here first. Okay, so without further ado, let's just run this. Okay, so if you look at this closely, this is definitely correct because we're visiting 15 first, being it's, let me use a different color here. This is correct because we're visiting this first. And as soon as this is visited, right, this is done, it goes into the next one, which is my pre-order. And the pre-order is going to follow this line again, null, not node, not null, and system out print line value. So this one is going to be printed second, right? So it's going to be 15, right, at this point, and then 10. Okay, so, but we're not done because once you're through with this one, and what happens? There's more calls, right? There's more calls to it, and what happens is you're recursing to the left again. So this is going to be left, right? And then at that point, 8 is going to be printed. So that's that. Now there's going to be the base case here. This 8 reaches the base case with respect to node not null, because there's actually left and right as well, but these are pointing to null. Okay, so this is null, and this one is null as well. Okay, so that entire recursive call kind of ends on the left side. And as soon as that is done, it goes into the node right. Node right is done, so it kind of goes back up to 10 again. And 10 is going to go into this right. And its right is going to have 2. Okay. And so on and so forth. Eventually 20 is going to be printed. So you can see that the recursion kind of just goes back and then come back down. It depends on the order. So this is a quick illustration of pre-order. You can extrapolate what a post order would be, and that would have completed all of our discussions on binary tree traversal.